Hello. So for our project called SAT Scholastic Aptitude Test, we are analyzing and exploring data from SAT scores in New York City and looking at what the most prominent factors are that contribute to higher scores. Our research question is which of the following factors, socioeconomic status, geographic location of school and neighborhood, and race contributes the most to higher SAT scores in New York City? Historically, these tests of intelligence were meant to measure aptitude. However, they've often led to some kind of discrimination, whether that's financial discrimination or racial discrimination. And due to the structure of the SAT, it's typically seen that wealthier families are often able to spend more money on preparation for the test versus lower income families. So our hypothesis for our project is that we predict that the location of students' high school attended and financial statistics associated with that area will be correlated to SAT score performance. And we think this is because the schools are located in a wealthier area and are likely to have students that come from wealthier families. And we believe that this will determine the certain accessibilities that the students will have in preparing for the test.
As far as our data sets go, we used a couple different ones. So the first one we used was the average SAT scores for the New York City public schools. Next, we used the New York City SAT results, and we have the link to the CAGL website as well. And then we used the 2013 to 2018 demographic snapshot school. And then we also use the demographic statistics by zip code. And for these data sets, we will include the SAT scores from New York City schools, the location of the high schools, and the various demographic data of the neighborhoods or the school districts in the New York City. And then we would also be storing this in a CSV, which would be easily available to pull into Pandas for analysis. And we're assuming to have around 100 different high schools in the New York City data set and more statistics around each neighborhood that these high schools are in. And then we will also be able to pull this data through New York City's government website, which is also linked right there. And the data will be kept within the GitHub repo unless it becomes unreasonably large, which we aren't predicting will be the case. But that is all for the data sets.
To begin, we stored our data sets in CSVs and run them into Pandas data frames. We joined them all on the school DBN, which is a unique identifier for all schools. We dropped all the K through 8 columns because they were unnecessary for our purposes, as well as dropping all redundant columns that come along with merging. The cleaning process mainly involved removing all null rows, as well as making all the date columns uniform and datetime objects, and creating a more general SAT score. Our EDA consisted of looking at more of the general distributions that pertain to our problem. So here we would just group by borough and look at some gender and ethnic demographics associated with each. We're also just between all the boroughs, just looking at what is the breakdown of demographics between each borough, as well as how that pertains to SAT scores. We also see in this graph that there's a heavy Hispanic population in most schools. Yeah, and then we go into looking at what are the characteristics of the top 10 scoring zip codes and what are the characteristics of the bottom 10 scoring zip codes, just kind of get a feel for the data and comfortable with what trends we are seeing.
To validate what we found in the plots, we decided to do a bit of regression. In the plots below, you'll see the general trends in regression with the number of students who tested. There's a correlation between poverty and the number of students who take a test. The more students who are in poverty, the less students who take the test. You can also see that down below, we have a general correlation between race and SAT score. However, we can also see in this plot below that poverty has a heavy influence on SAT score. As the higher percent poverty, the lower the SAT score tends to trend. We also built a regression model. Putting it all together, we'll see that our model reaches its highest accuracy of 85%. This indicates that all features contribute to the SAT score predictions, but generally economic factors play the biggest role in determining your SAT score, with race following in a close second. It's also possible that these features are tied together, such as different areas that also happen to be highly dense in one race are also areas that are in high need, or areas that are dense in another race are also areas of low need. We also plotted some scatter plots just to confirm that we didn't have any sort of confounding variables. So this correlates that while different areas might seem to have a correlation between SAT score, in reality, it's the economic need breakdown of each of those areas that actually contribute to the SAT score. If we scroll down more here, we can also do an investigation based off of race and see if there's any correlation between race and SAT score, and see that there is a general trend, but these trends also closely follow the socioeconomic trends, such as SAT score versus economic need.
For ethics and privacy, there's a potential bias in our dataset due to the fact that the data being used was collected in 2012 instead of currently. There may also be a slight bias in our data due to the fact that we are only analyzing data from public schools, not private schools. Additionally, another potential limitation is that we are analyzing only the data of students who took the SAT and not the students who took the ACT. Also, the data does not provide information about how many times a student took the SAT or how much outside practice the student had prior to taking the test. For our conclusion, after analyzing our datasets, our conclusions support that there is a correlation between higher SAT scores and socioeconomic status, as well as race and location. These findings support our initial hypothesis. However, while we did find correlations between the features we examined and SAT score performance, it is important to note that correlation does not imply causation. For our team contributions, our group of 5 collectively met weekly on Thursday mornings to discuss project plans and to work on the research and analysis for the project. For each project check, we agreed as a team to work on certain sections. We all then filled out our team evaluations and worked on the final video together. We all examined the final project together before submission.